morning. Well, morning, everyone. If you're involved in any exploratory data analysis, it's tedious. You normally want to cut down through the different layers of your data, and that involves very repetitive functions. So you might, let's say, have a study with 100 participants, and you've got multiple measurements in each one of those participants. So you then want to cut down through each one of those participants and see their individual data. That involves a lot of iterative processes over and over again over each individual, which can, as I said, be time-consuming and boring. So what the goal of this is to do, this presentation, is to say, how can you make that a bit more efficient? And the way I'm doing it these days is to use the map functions in the purrr package, which is one of the tidyverse packages. And what you do with the purrr package with the map functions there is you take a list data column, which is essentially a compressed data, which is over here, and you apply a function using the map functions through purrr, and you get some sort of output which you can use. So it just helps to iterate over processes. So it's essentially a glorified allapply function. But it has some better extensibility, which I'll get onto later. Now, I'm going to work through the examples I want to deal with using it's actually a real data set which I've modified. You can download the original data there and install it as a package. And it's the carrots data set. And the carrots data set originally comes from the Lima test package, but I've trimmed it down to 103 people. And they were exposed to 6 different types of carrot. Who knew? And they were asked to talk about those carrots in terms of their overall preference. So in terms of the taste, 1, I hate that carrot, 7, I love that carrot. And also the attributes of that carrot, its sweetness, its bitterness, and its crispness. So various aspects of the carrot. If we look at the data, it's in a wide format. You've got product over here, so the different types. You've got the preference, which is a score of sweetness, bitterness, and crispness, so the different attributes. And then they also collected interesting data on what they thought might influence your carrot preference. So things like how often you ate carrots, what your sex was, biological sex, what age group you fell in, your employment status and income category. Who knew about carrots and the finer art of carrot testing? But there you have it. Now, for some of the data analysis I'm going to use, the data needs to be in a long format. Right now it's in a wide format. All these are attributes of carrot taste. So I have gathered the data using the tidyf package into an attribute and ratings group over there. So just be aware of that. But I didn't really know what they wanted from this data set, so I thought, okay, if I was exploring this data set, what would I want to do? I would want to know the preference rating and its rating and its association with tasting attributes, so bitterness, crispness, sweetness, by carrot type. So if I was first looking at the data. So just have a quick overview of the data. So that's the question I decided to ask about these data. Now, when I first started at R, I knew base R and I knew base graphics. So my way of going through this would be to extract from the data set using standard indexing out each carrot and then apply to each carrot a certain plotting function using base graphics. And what I'd get would be something like that. But then I would do that over and over again for every single one of those. Now that's fine when you've got 6 carrot types, but what happens when you've got 100 people, 1,000 people, 10,000 categories you want to scan over? It becomes very cut, paste, find, replace in terms of the names. It becomes very laborious. So give it a little while, and I'm showing Stack Exchange, and people keep on using the split and apply way of doing things. So, what do I need to learn about this? So then you learn about the split function. You take your data frame, you have some other grouping variable over here, and you can split your data frame. In this case, I've called it foo list. And just to show you what it looks like, you've now got a list, and I've taken the top 2 lines of each one of those, and you print out that list. I've now got a list of length 6. And each one of those includes a data frame, including each one of the products. So there's the Bolero, there's the Navar, Major, Navar, etc. types of carrots. Then you can use the apply functions, and there's a suite of them, but in this case it's a list, so I didn't want to simplify it, so I did the lapply. And the lapply works really nicely. All I did was take the data and shoved it into a function. In this case, the function is a ggplot function doing the relationship between rating and preference. And are faceted by attribute. And what do I get? without any cutting and pasting, just using split and then lapply, I can pump out the same graphs for every single one of the, so there's 6 different types, so I've got 6 different graphs, depending on what I want. So that's much more efficient than the old system of doing my, essentially brute forcing it the other way. But it seems like things move on, and the tidyverse is taking over. And I think it was on Twitter that I first came across the whole thing of list columns and purrr. And in terms of list columns and purrr, you take a list column, you purrr through it, and you have an output. And so it looks pretty much like a lapply function. Just before I go on, just in case you don't know what a list column is, and believe me, list columns, I thought it was a Hadley practical joke when I first came across list columns, because they just seemed like an overcomplication to me. But essentially, you take a data frame. In this case, I've got brands, Heinz versus All Gold, of tomato sauce, the country, and the price on Amazon. All you do is you try group it by grouping variable, and then you nest it, and then you've got this nested data. So your data gets shoved or compressed into a smaller form, which can then be accessed through purrr, and so that you can apply your function. Just to confirm that, I've nested this carrots grouping variable. There's your product, your grouping variable, and inside you've got a whole lot of data frames. Now, the map functions are probably the thing I use most in the purrr package, and also walk. And walk, there's the difference between map and walk. Map takes data, applies a function, and gives you an output. Walk takes data, applies a function, sends your data out as it was, but you get the side effect, so such as printing a plot, which is then it's going to be a side effect that you want. Map, the standard function, 1 data input, 1 output. Map 2 and walk 2, 2 data inputs get used by the function, and then you have your output. Pmap is you take any number you want, greater than 2, and you shove it in there, you apply your function lots and lots and lots and lots of times with lots of different data inputs, and you get the output. Looking first at map, just the map function. So, what I have over here, I've got foo, which is a compressed, which is essentially the nested data set of the carrots. I mutate, so I want to add a new column, which is called plot. I use the map function, I tell it where to find the data, and then I shove that data into ggplot, which is the exact same ggplot I used in the lapply function. And what it does is it produces a new column in my data set. So there's product, there's the data, and now I've got a ggplot object in each one. And each one of those ggplots applies to the data associated with it. And then if you walk through that to get the side effect, I can walk through those data, foo plot, print, and you get all the plots out. That's exactly what I got with lapply. So where do I want to improve this? Well, let's say you want to use map 2. In map 2, you've got 2 data inputs. So this time, what I've done is I've got the foo, the nested data set. I want to mutate a new column called plot2. I'm going to use the map2 function. I give it 2 data sources, .x, which is the data, which is the original data over here. But I'm also going to take the character, the product names, which is this column over here, and I'm going to put it into the ggplot. I put the data into the ggplot, and I've added a labels column, a labels function over here, where I want to add the name of the carrot. And then I apply that. I get a new column over here. I can walk through it, and suddenly all my plots have a nice little name to it. So you've got a little bit of gee whiz over there. Okay, now I can actually identify the plot that goes with the data set that I had. Still nothing revolutionary there. But what happens if you start to dig a bit deeper and you start to have more data inputs? So now I want to know, I have been saying preference versus tasting attributes by carrot, but what happens if I want to start dividing it by an attribute? So let's say a demographic attribute such as age group. And I also want to include some other types of summative data in there. So here I'm doing a map function again, and you'll see where I'm going with this in a minute or two. So I've got foo, I've got a mutate, and I'm going to add a new column called data2, but in this data2, I'm going to take the data from data, which is the orange block over there, and I'm going to use a summarize function to produce a median and 25th and 75th percentile, and I'm going to do it by age group. And that's the data I produce over there. I can then use the pmap function to take 3 sets of data in this case. I'm going to mutate, I'm going to take the nested data set, add a new column, plot 3, I'm going to pmap it, but now you use a list. I've listed the first data set, which is that one, list the data 2, which is that one over there, which is the new summary functions, and then the product names, which are over there. and I shove them into my ggplot, and I just have to reference them. The referencing for pmap is a bit different from the other map1 and map2, where you just index them with first in the list, second in the list, third in the list, and I've now faceted by attribute and group. If I walk through that, I then get this data set. I've now got, through plot, I've got each one of the different carrots, and I've now got it by bitterness, crispness, and sweetness. I've got a line showing me where the median rating of preference was, and I've got for each one of the age groups. And you can keep on sort of adding data sets, and you can, and the sort of things you can put into this. I've made it very simple here, but you can do bootstrapping, you can add, you can do modeling over and over again, you can do what you want with it. And what's really convenient is what you can put into these functions over here. Because to add a function, you just put the little tilde signs, the little squiggly bits over there, and you write your R code as you normally would. Only thing you have to do is reference it to where it must get the data from. And then it just seems to do its stuff. So, I hope I can convince you of something, that you do have the ability, the allapply tends to take one data set, map gives you that function. So map, you can use allapply. But if you start to have lots of data inputs, it's got a big benefit in terms of using the purrr functions, map2 or pmap. It really can extend what you want to do and allow you to iterate very quickly over reasonably sized data sets. I don't know about very large data sets, but reasonably large data sets you can iterate over very quickly and produce your exploratory analyses quite efficiently. So there are advantages and disadvantages. Disadvantages, it can be quite verbose in terms of how you write it down. Depending on how long your functions are, it might be you want to predefine your functions and then put them into map. And you can get into nest hell. The first time I used nesting, I think I got 3 nests deep, or 4 nests deep, and I didn't know how to get my data out again. My indexing skills weren't good enough to get the data out again. So you can have the problem of indexing too deep in terms of nesting. The advantages are it's compact. Now, I said it's verbose over here, but that's because the functions can be quite verbose. But it's compact in terms of if you're doing exploratory analysis, you often find in RStudio, you look at the environment and you just got lots of little objects floating up there. Here, you're keeping everything within the data frame in which the data was sourced. It can mean if you've got very large data sets, you can get a data frame bloat. But as long as your data sets are manageable, and most of the things, at least from the biological and biomedical sciences, they tend to be tractable in terms of the bloat. It does keep your environment very compact. It's very easy to define functions, and I'll go down to the bottom one over here. It plays nicely with everything. If you can write a function in that, using a certain package or whatever it might be, you can shove it into purrr, and it will iterate that function over your data. So it plays nicely with the rest of the R universe. And the other thing is, as opposed to the lapply functions and apply, or the apply and tapply, etc., it does very nicely with multiple mappings. It makes it very easy and efficient to do multiple mappings. You can get all the data from there. I've also got the analysis script up there, and I'll put my slides up there later if somebody wants to go play around and see how I generated any of those. And with that, I'll leave you with that.
Thank you very much, Peter. That's right on time. We actually have 2 minutes to spare for your talk, so we have quite a bit of time for questions. If anyone would like to do that, please put up your hand.
If not, it was a dry topic.
I was just curious when you mentioned sort of the motivation of starting to use purrr with handling large data sets. I mean, does that mean that you have noticed performance improvement for achieving the same end through some of the mapping functions?
I think it's improved the... it takes me less steps to get where I want to go, especially if you're subdividing and subdividing and subdividing your data as you bury down into data. Often in terms of my data analysis, I'm looking for the anomalous data point, something that I need to look at more carefully before I go do a global analysis of my data, answer the question the data was designed to answer. So it's about data cleaning. And often you keep on wanting to divide and divide and divide, and this nesting function just helps you get down there quicker and in a more efficient way. I've definitely noticed an improvement in the efficiency of which I can dig into data using mapping functions and nesting. Because I've shown nesting at one level, but you can nest at 3 or 4 different levels. And you can sometimes get there with, let's say, faceting, but generally my rule of thumb is if you've got more than 3 facets, then you can't see what's actually happening on the plot anymore. So by nesting and then plotting within the nests, you actually help to expand your figures up again because you've removed one of the faceting components up to a higher level.
Thank you. Any other questions? We have about 4 minutes left.
Have you used, I think it's called invoke map at all, the other set of functions with your kind of exploratory data?
No, I haven't needed it. I've seen it, but I haven't used it because I haven't had the need to actually use it. It's one of those, I tend to learn R as I need it. So I learn as I need it, not rather than ooh, that sounds nice. I tend to find new functions when I have a problem in Search Stack Exchange or something like that, or Google something, and then you find new stuff. But sorry, I can't answer your question there.
Thanks. I also use the mapping things quite often, and this is more like a philosophical question, but don't you find that map2 becomes irrelevant if you've got pmap? Because now your sort of syntaxing changes, where like if you only use pmap, it stays .. .1 until .n. So I don't know, have you found that I sort of have to think about, not actually using map2, but just using pmap all the time rather?
Yeah, I tend to. I think when I first started, I was a bit nervous about pmap, and that took me a little. For some reason, the .1, .2 thing I don't know, it just threw me at first because it goes .x and then .xy for the pmap, and then suddenly you got .1s. It just like why the change in the syntax? I suppose there are only so many letters in the alphabet, but there's nowadays I just go straight to pmap. I'm either using map or an lapply. Actually, I often use lapply instead of map. But then when it comes to multiple mappings, the moment it's 2 or more, I go to pmap.
I was just going to say, when you do that pmap, if you give the list names, you don't need to use the .1.
Don't you? Okay.
You just use the name that you pass in.
Okay, I didn't know.
Which makes
every day's a school day. Thank you very much. That makes it much better. Because then you're not having to track what belongs to what. Yeah, that's cool.
Okay, great. Any other questions? Right.
Thanks very much. Cheers.